DevelopSec, Developing Security Awareness with James Jardine, brought to you by Jardine Software. Hi, and welcome to episode 20 of the DevelopSec podcast. I am your host, James Jardine, and today I want to discuss a little bit about some of the lessons or takeaways that we can take from the recent public disclosure of some security vulnerabilities in the MoonPig API. I know when I first heard MoonPig, I actually thought it was like a new name for some sort of exploit, but what they are is they do like e-cards and that type of stuff. It's a website where you can order cards. And basically what happened was that there was a security researcher that stumbled upon in the Android application, watching the calls going back and forth between Android and the server for the API. He noticed that there were some issues with how the application worked. So, for example, there was an issue of the authorization and authentication wasn't quite what it should have been, starting with the fact that it used base 64. It used basic authentication, which uses base 64 encoded username and password values. That in itself isn't really that big of a deal because they actually were using secure channel, right? They were using HTTPS, so the data is protected in transit, which makes it no different than, forms authentication that we see in most web applications where, right, we have to use HTTPS to protect our username and password because it's submitted in clear text. Basic authentication just submits it, but they actually base 64 encode the username :password. So the notice of this was of some significance because they are using something that has some downsides to it. Basic auth doesn't have any type of brute force protections, so somebody could sit there and try to brute force the username password combination. But actually, what they found was it was a set of hard coded credentials that were being sent. They weren't the credentials of the actual user. It was actually like just a system credential to call out to the API. So I wanted to take a look at some of the things that we're seeing and talk about some of the ways that we can get around this and hopefully in our applications not fall victim to these same things. So using that one as an example, basic authentication, again, not that big of a deal that they're using basic, but there are definitely better authentication mechanisms out there, such as using OAuth, OAuth2, some mechanism like that where we're using tokens, because there's a lot of built-in security features that come with those type of authentication, right? As I mentioned, basic doesn't have any type of replay protection. It doesn't have any type of signature. It doesn't have any type of brute force protections. But if you start looking at OAuth, for example, which is fairly common when you're using mobile devices to connect out to an API, there is tamper protection with a digital signature on it, right? They're hashing it and signing that message so that way if somebody intercepts it, they can't tear it apart and mess with it or even see what, they can see it, but they can't mess with it, right? They can't tamper with that data, which is a good thing. Also, they provide anti-replay, so if I capture a request, I can't then keep resending that same request because they have timestamps on them. So they're built to stop you from doing that. They're done over secure communication, hopefully, and it provides limited access to what's going on with that. So when you're thinking about the authentication for mobile applications to reach out to an API on your servers, you really want to give consideration to what is the best option. And as I mentioned, basic works. There are very prominent companies out there that use basic authentication for their apps to talk out to their servers. But as I mentioned, in this case, they were actually using a set of hard-coded credentials, which really limited down how they know who's connecting. Usually you're using your authentication to be able to provide that authorization, which is our next step. Because if I don't know who you are, I don't know what you're able to access. And in a site like this, where I can go up and view my own information, maybe I can pull down, I think they listed on their site that You could pull down the last four of a credit card number, your expiration date, your name. You can make purchases. So there are some things you can do with this account. So there must be some way for me to be able to say, yes, this is me, right? This is me, James Jardine, not John Doe down the street. So if we're passing up hard-coded credentials for authentication purposes to the API, well, how do I know who that is? And it looks as though the way they were trying to determine that was there was some form of customer ID field, which is just a numeric value that identified, hey, I'm customer number 5678. Right? And we see a lot of systems do this. Look in your URLs. You see this all the time where it's got your customer ID, some ID value up in the query string. Well, okay, so that works and says, hey, this is the customer I want to pull. But again, just because I'm passing up that value doesn't mean that I'm necessarily that customer because, again, you authenticated me as the system. You didn't authenticate me as James Jardine. So if I'm able to manipulate that ID value, and this is what the researcher did, he actually went in, manipulated the value. He had some test accounts that he was playing with. I won't get into my thoughts on security research, but test accounts that he was using, so he wasn't using anybody else's accounts, was able to change that account number and be able to view other people's information. And this really it's more of an authorization issue. I mean, we call it a direct object reference, where I can change that value and I directly get another object. And the values were incremental. It's not like I had a random ID. If I had 5678, 5679 was somebody else, 5676 was somebody else, right? All around them are other IDs. So this is where that authorization comes in of once I know who I am, now I need to determine what can I access. So if I'd authenticated with my credentials and it said, hey, yes, you're James Jardine and your customer ID 5678, well, then if I try to access 5679, the system's going to say, wait, no, that's not your record because that's not tied to my account, right? And they know that because they authenticated me because I sent in my username or password or I sent up my auth token that previously used a username and password to authenticate myself to say, yes, I am me. And then the system already knows, okay, well, you get access to these records. And so this is very commonly missed because oftentimes we think of authorization as at the page level where, oh, yeah, I won't let you get access to that administrator page. But when we look at authorization at the row level, we often overlook that value. And it's been seen in multiple cases throughout the past where credit card companies have had IDs in the query string. You modify it, you could see values. The AT&T deal when the iPad first came out, and somebody went through and actually enumerated all the IDs, and it gave back email addresses and information about the person that owned that iPad. Is another way where it's, hey, I'm not checking at the row level to see, hey, do you have access to this record? And sometimes that can be difficult. Sometimes it can be very simple. But it's something we need to think about because we need to make sure, especially when we're dealing with a system that has sensitive information, whether it's credit card information, health information, even, mortgage, whatever it may be, right? Anything that's sensitive, personal information that shouldn't be shared. We need to think about, hey, can somebody else access this, right? So we have to be looking at that. And as a QA person, right, when something comes to me in QA and I'm testing an application and I see that there's a value on the URL or I see a value that's being sent up that's numeric like that, I should be thinking about changing that, right? I should have a test plan for that field. What should be a valid field, right? What should be a valid value for that field? My user that I test with is user 6, and I know that user 8 I don't have permission to. Let me make sure I don't have permission to user 8. Now, I caution you, make sure you change up who you don't have permission to, because while hopefully not very common, we have seen developers in the past find out that, hey, they're going to test to make sure they don't have access to user 8, so I'll hard code user 8 as denied, and then user 9 has access. So you want to make sure you're switching that up so you don't get caught in a situation like that. But as QA, we should be testing that type of stuff. We should have a plan we should know everything on that query string, all those parameters, what are they used for? How are they used? So that way we can effectively test them to be able to test that authorization issue. And we should be using proxy servers. I don't know how many QAs out there are using proxy servers like Burp or Zap or some other proxy server that's out there, but we should be looking at that traffic going back and forth. We want to see, because maybe it's not on the query string. Maybe it's in a post request and you don't see it in the web browser, but you see it in the proxy. And just because you didn't see it in the web browser doesn't mean it's not difficult for the bad guy or the guy trying to play good for them to manipulate that value and then see data they're not supposed to see. Our goal is we want to protect as much information as we can, right? I think most companies want to protect the information they can. I think the problem is we don't have a lot of solid foundation and education within the dev and QA side for thinking about these type of things that the attackers are doing. And they're simple things. I'm going to tell you now that modifying an integer value on the query string or in a post request is very simple. I mean, I could probably get my 4-year-old to do that. It's not hard. So we should be checking this, because if you're getting breached by something as simple as that, it's a foundational issue, right? We're not being properly trained on how we should be testing this. And I said, it's not hard, right? This is something that every one of us can do. Even if you're testing via Excel spreadsheet and written out scripts, make sure you have scripts for those fields. So that way we can start testing those. Developers should be testing it as well, right? Developers should be thinking, hey, I use an ID field here. It's a numeric field. How do I handle that? How do I make sure that when I pass up this 6, I know that the user that is accessing it has access to that field? It shouldn't just be a trust issue, right? We don't trust in the development world when we talk about input coming from the user, because even if you've hard-coded 6 into a hidden field, right, the attacker can easily change that. That's very simple. Anything coming from the outside, right, untrusted input, we can change it. We can modify it, and even though you might think that it's not changeable, in most cases it's going to be, right? Unless your hidden fields have digital signatures on them, so you have some form of tamper protection, we can change those values, right? So we want to make sure that we're thinking about this. I remember sitting with QA a couple years ago, as one of the guys I was showing him a different flaw, and we saw something else with an ID field, and it was in the query string, and I was like, well, why don't you change that number? And, you know, it struck him as odd. He was like, I never thought to change that number to see what would happen. And I hope that to this day now he thinks about that and does that, because it's a critical during our testing phase that we think about that, right? I see something in a query string, I see a value up there, can I change that? Right? How many times have you seen systems pass up data in a query string or in a post value that happens to be the fields that they're pulling from the database, right? And you look at them and you're like, you know what? These are the fields. I mean, there it says right there, username, address, phone, and then the results that come back maybe as a JSON object that has username, address, phone. Well, let's look at that. Let's think, hey, can I actually change the fields that come back? What if I add a field to that and say password, or something that I might think might match the naming scheme of how they're doing it? Hey, let's check that. Let's make sure I can't pull back more fields than what we're expecting to be able to retrieve back. And if we can pull back more fields, let's make sure they're not sensitive fields like your password or some sort of key or encryption data or something like that. Let's make sure we have it limited. So I think there's a lot we can learn from these incidents that we see come out. And while there wasn't a breach that we're aware of, besides a security researcher doing the stuff that he did, we're not aware of a air quote malicious breach that occurred within the site, which is good, but it may have happened. Maybe they just don't know, right? How many sites have been breached before that they've been breached for months, maybe years, and have no idea. So we want to make sure that we do these authorization checks. Additionally, we want to think about brute force or anti-automation protections. Having an ID value like what we saw in this case, right? If I can increment that, it's easy for me to throw that into a quick Python script. I can throw it into Burp's Intruder. I can throw it into a bunch of different tools and just say, hey, increment by 1 and just keep pulling data. So if there is an availability where there's authorization is missing and I can pull data, well, now all of a sudden I've got the ability to pull everybody's data in a very quick amount of time. I mean, they're talking 3 million customers. So you know what? I mean, you're talking maybe an hour to pull that, depending on how your setup is. Could be shorter, could be longer. To actually scrape the entire database to pull information down. So you want to think about that, right? You want to think about how can I protect this? Now, anti-automation can be a little bit more difficult when you're talking about an API. Whereas on the user interface, we do have cool ways of doing like CAPTCHAs and other ways to force the user into slowing down their requests. But the API, right, I mean, we can come up with ways to be able to track this, right, whether it's by IP address. There are different things that we can try to pull to be able to identify this because we have to figure out how to do it. We want to stop that ability to brute force so that in the event that for some reason that authorization check has been missed, it's going to take somebody a manually long time to be able to pull all the data that you have out there. So we want to slow them down. The other option we have to stop the tampering of the data, and again, if we use something like OAuth or something where we have tamper protection, we've got that. But we've also got certificate pinning. Now, I know there are ways out there you can bypass certificate pinning. If you root your phone, if you do this to your phone, you can do that. You can bypass it. But the idea behind certificate pinning is that on my mobile device, I'm going to say in my app, I'm only going to trust this specific certificate, or I'm only going to trust trusted certificates. But in most cases, it's I'm only going to trust a specific certificate. And there's a bunch of ways you can do it. You can look them up online. OWASP has a big page on certificate pinning. But the idea behind it is, look, if I'm going to just trust this specific certificate and my site connects over a secure channel, well, then when I'm trying to do a proxy man in the middle, like Burp or Zap or whatever proxy people use, that proxy, in order to be able to intercept and read the traffic, has to be able to, on a secure channel, decrypt the traffic and then re-encrypt the traffic. So what happens is, I make a request from my browser, it goes to the proxy. The proxy is the one that's actually giving me the certificate, right? So I'm getting the proxy certificate, so whether it's PortSwigger or the certificate you created out of Zap, I'm getting that proxy, and then Burp is actually dealing with the proxy from the actual end client, that API that you're trying to call. So in most cases, if you're not using certificate pinning, and I'll use iOS as an example, I can go in there, I can pull down the Burp certificate onto my phone, I type in my passcode, and I can install it, and now I can intercept traffic. With cert pinning, unless I find a way to bypass it, and as I mentioned, there are ways to bypass it if you're doing some funky things with your device, unless I bypass it, the app probably won't even work because it'll say, no, I don't know this certificate, so I don't work with this certificate, right? The only way I'm going to work is if I talk directly to my server and I get the certificate that I expect. Now, there are some downsides to cert pinning, especially if you're dealing heavily in a corporate environment where there's proxy servers that you're forced to go through. That could cause an issue. Depending on the type of application you're running, really heavily determines whether that's a big deal or not. Things like the Gmail application, right? They don't do cert pinning, but they're also in a lot of they're in environments that it's probably not really feasible for them to support cert pinning because it would cause more problems than it would help. And I honestly feel that if you're doing everything else right, if you've got tamper protection, if you've got all this other stuff, you're not passing sensitive information across, well, okay, so somebody intercepted your traffic. But if I can't change anything, well, that's not helpful. If I'm not seeing anything that's not mine and that's sensitive, okay, well, there's not really a big problem there, right? If you're doing everything else right, it's just one of those added benefits, but it's not for everyone, right? It's not going to work everywhere. So I think, I think there's a lot we can learn. I think we spend a lot of time looking at the negatives to when we see public disclosures being released, when we see breaches happen. And the goal I have with this podcast, with the website that I just put up, that's now available. I've started posting. Actually, most of this information is in the form of a post as well. So if you don't like listening to my voice, which I understand completely, you can actually read it on our site. But this year I just started the site where I have the information. And my goal is not to look at all the negatives that are going on with some of these situations, but let's take them, let's break them apart, and let's actually learn from what's going on. Let's learn from mistakes that people have made, and then we can start understanding, oh yeah, you know what, I'm seeing over and over again, row-level authorization is not there. So I really need to make sure that I have this going on, because that seems to be pretty common in a lot of these breaches or disclosures we're seeing. Cross-site scripting, SQL injection, whatever it may be, we'll start to pick up the trends of what's going on, and we'll start talking about them more and more, and we'll discuss, how can I get around this, right? What are my options for this that'll help out? Maybe I don't understand something about it, and that's my goal here. My goal is to help understand what the flaws are and understand what we can do to hopefully make sure that we don't have them in our own systems, so that way we're not falling victim to any of this, and that we're doing a better job protecting our customers, right? This is not the venue that I'll be using for spitting negativity. Oh, they did this horrible, they're horrible, right? Nothing like that, right? People make mistakes. Applications have code that's vulnerable. And I think we need to look at it. This is 2015. We need to look at it in a way where we benefit from it. Just complaining about an application is not going to do anything. Benefiting from, hey, this happened, let's learn from it, and we'll add it to our list of things that we check and make sure that we're not doing that as well. So hopefully you got something out of this. Please feel free. Send me email if you would like with questions or anything like that. You can just send them for now to my james@jardinesoftware.com address, as I get that most frequently. Versus I haven't really set up a bunch of addresses besides the podcast address for the DevelopSec accounts at this time. But feel free, reach out. I'm on @DevelopSec on Twitter, or you can reach me at Jardine Software on Twitter. And, let me know if there's something you have questions about. If there's stuff you think is interesting, feed it over, because I'd love to be able to share that information and just help promote sharing the information for other people and help everybody get a little bit better. So I hope you enjoyed this one, and we will be back again soon for our next podcast, where we'll pick some other topic. Maybe we'll have something cool in the news that we can cover to hopefully learn from. If not, we'll come up with something else. So thank you, and thank you for listening. You can find all this at www.developsec.com. You have been listening to the DevelopSec podcast with James Jardine. Follow us on Twitter @DevelopSec and visit our website at www.developsec.com for more episodes and information.